All right, and now we're into section 5. We're going to see a different application of curve fitting. So we've done, this is a screenshot of the image that we just saw with phase, amplitude, and mean NDVI information. And the rich thing about curve fitting is that we can view the data in different ways. So we're gonna do a different harmonic fit for the same image. So the first one, as we've seen, we are using HSV values, and then we had sine, cosine, and DVI. Now we're gonna do an actual like RGB, but we're gonna use sine, cosine, and slope instead. So we're gonna go to checkpoint 46D. And by slope, it's really, if I'm not mistaken, the time coefficient. So let me go back here. I'm gonna go all the way down to section 6. Oops. Yes, that's section 5. Pardon me. So here we're just grabbing another point just because it's a good example for the section 5, and we are centering the map to that point, and then giving it a higher zoom level so we can see the example. And then what we're doing here, we are grabbing the slope information. So this is pretty much what we do all the time. We select the coefficients, we get rid of the residuals, then we flatten as well, but here we're selecting just the time information. And then we are creating this image, another view, which we are grabbing the sine, the cosine, but we are using the t information instead of the mean and DVI. And we are just adding that to the map to see how it differs from the other visualization that we had that used the mean and DVI. And it results in a pretty image. So it takes a little bit to load, but the idea is that with different combinations from these different variables, coefficients, you can get additional information that might be important when you're predicting your phenomena. So this is the original image, and this was like HSV. So the color means different colors mean different values of the sign or the phase. How far it differs from white until it's very vivid color. That's the amplitude information, cosine. And then if it's black, it means like low NDVI values. If it's really white, it means high NDVI values. And then we're gonna have another image on top of this one, which is gonna have completely different colors from what we're seeing right now. Hopefully we load quick. And that's because we're using, instead of HSV, we're using just regular RGB visualization parameters. And instead of ANDVI, we're actually looking into the time information, so the slope of the slope coefficient. And you can start seeing that that image is getting added to the map. And you can see that it is completely different from what I've seen. I think the zoom level is a little too zoomed in, and I'm afraid to zoom out and start the whole process again. So I'm just gonna wait until this loads. So here we can see, for example, these crop lines here on the left side were mainly with this red, or pardon me, mainly with this green color. Right now they are at all different sorts of colors. You can see it's not only green, you have yellow, red, pink, and that's because we're displaying different information. And same with the city. We had mainly the city here on the right side had mainly this green and blue color, but now we also see some other colors popping up. And if I inspect a value here for there's another combination of fit characteristics. This is actually, the values that we see for sine, cosine, and sine. Let's see if this is gonna take too much. I'm gonna pause here, but if not, we can talk a little bit more about this